while maintaining a high engineering bar, which is super hard to accomplish. And that's because of the seasoned leadership of people like Gaurav Maheshwari, our next speaker. Gaurav was a principal engineer at Rubrik and vice president at Goldman Sachs before that. He joined Oodle as a founding engineer and has been foundational in building this product and the team from the ground up. Please welcome Gaurav Maheshwari.
Yeah, thanks for the kind words. Cool. So yeah, I'm Gaurav. I'm a founding engineer at Oodle. Oodle is an observability startup, so we have been trying to solve the pain points which exist in this space. As a side hustle, I'm a poet by heart, software engineer by profession. So I connect software engineering with poetry, and one of my LinkedIn pages code poetry. So I have been a founding engineer at Oodle for the last 11 months. Prior to that was at Rubrik, working as a principal engineer in some of the product and platform teams. Do a bit of poetry and software engineering in a day-to-day world. To give a bit of context about observability and Oodle, so with the move to cloud and AI, like observability, there are new set of problems which are emerging. Like earlier, let's say 6 years, 8 years back, products like Datadog knew that like what they solved for is unified observability stack, like where you can pump all your data to a single place and then have a single pane of glass visibility. But with the more sort of as your deployments become more distributed or so, the cost angle of observability has been shooting up for last several years or so. So observability became too complicated, too slow to debug things, where you will constantly see on-call engineers spending quite significant bandwidth in like trying to connect the dots or so, and obviously too expensive because too expensive because of like all the high volume of data which observability generates, and then a need to store that also. And with the AI coming up, like there are tools which can generate a lot of code faster or so, but there is still problems to be solved, and how do you maintain those applications in production, like how do you debug them faster or so. So that's what Oodle does, and the way we achieve that is we built a storage engine which stores all the observability data on S3. So that's where we developed our own storage format and the way we access this data in a performant manner. So that was our attack angle for making observability cost effective, right? And then data being present on S3 allows us to use Lambda functions as well as compute to be able to serve the queries. One of the other sort of properties of observability data is it is obviously not read all the time. Like when there is an incident happening, then maybe 10 engineers are looking at dashboards or logs or whatnot. Rest of the time that data is just sitting idle or so. And due to that nature, it is also that there is your idle query load versus your peak query load is quite different, and that's where using serverless functions we can keep the cost down during the idle periods, but also serve higher loads while being performant due to the nature of serverless functions. So this allows us to store huge volumes of data, handle higher cardinality, which is typically a challenge with observability vendors, because you need to monitor what's your cardinality. You cannot add customer ID labels to your metrics or so, because your bills will go high. And having information like that available in your telemetry allows us to utilize that for faster debugging or so, because then like we can connect the dots between, oh, when an issue happens, then which customers are impacted, because that kind of labels can be present in your telemetry data. So that's what like we do when an alert fires, that we can with a click of a button analyze a lot of that data and then provide you a summary of what's happening. Right, and why AI in observability space? So there are three main reasons I think where AI is extremely effective in this space in particular, where most of troubleshooting in our experience has been like connect the dots, like, and this is where you will see that sort of experienced engineer within the team would be able to troubleshoot issues within like few minutes or 30 minutes or so, but a recent joiner in the team could struggle with the issue for several hours or so, right? And a lot of this data is just present in the system. You need to know which dashboards to look at, which metrics to look at, which logs to look at or so. So with tools like AI, you can connect those dots, apply some level of reasoning on top of that. Right. Second is like almost all observability vendors or tools would have certain query languages which you need to learn. Like if you are dealing with metrics, Prometheus-like systems, then you need to learn PromQL queries, and when you don't know that, then you also become sort of handicapped while doing the production debugging, because you just don't know how to compute P95 of a histogram probably, let's say. Right? The third is observability data access is limited to observability tools right now. Like you need to go to your particular Grafana dashboard to consume that or so, but in a typical like end-to-end debugging experience, you are dealing with your Jira tickets, you are dealing with code and whatnot, and tools like MCP or so could allow access to that data in different integrations where it is most applicable or so. So with that, like I will show a couple of quick demos of like how we are using AI in Oodle and what kind of features we have been building and continuously iterating on. Yeah, so this is our alerts page, and what we do is along with each alert, what we can do is whenever it fires, we sort of give you insights associated with that alert. So let's say this alert fired around 10:12 to 10:26 a.m. or so. With a click of a button, what we have done is analyze like what was happening around that time with respect to this particular alert. So this alert is a alert on API error rate. So we can see that around this time API error rate shot up. Now the next questions as a on-call engineer I would need to answer is like, what's the blast radius for this issue? Like, is it specific to few services? Is it specific to few customers or so? And that's where having all the telemetry around what's happening in the system, what Oodle does when you click that button is it will analyze which of the dimensions is impacted. So for example, over here it says like 2 out of 139 HTTP routes are impacted. So this high error rate is specific to 2 particular HTTP routes. Then we utilize this information to generate a nice summary in terms of like what has happened, what could be the potential impact and suspect root cause, which is where this is saying that it is specific to this checkout service and having a high 4xx and 5xx HTTP response codes, right? And it also mentions like which HTTP routes are impacted, which is what this label drill down information gave it. To look further into those, you can click on these specific drill downs where you can see that okay, checkout and checkout submit was impacted around this time. And we will combine the metrics and logs, relevant error logs for that period around that time. And we also provide sort of like, most of the systems would be distributed systems where you need to walk across the services to be able to debug that. So over here, checkout service was impacted, and then you can see like UI service depends on it, which again depends on few other services or so. So when you want to look at, okay, what else is happening in checkout service, you can go and sort of like drill down into its dependencies, its APM metrics, its infrastructure metrics, logs, or whatnot. So that way, like with few clicks of button, like an on-call engineer hopefully has all the information which they need to look for that particular alert and able to troubleshoot that faster. And subsequently in our product, we also do want to sort of like effectively utilize the service graph information in your further drill down into the alert and better root causing of it also. So that's one thing. The second thing which I wanted to demonstrate was around the steep learning curve associated with like learning the specific query languages or so. And for metrics, PromQL is the most common query language which people use. And it requires some bit of learning for engineers to sort of look at it. Right? So what we have done is like sort of integrated an AI assistant over here where like you can ask questions in your English prompt, and then at the back end we will effectively see what all metrics exist in the system, look at their metric metadata in terms of like what are their units, is it a histogram metric or a counter or a gauge or whatnot, because that information is useful to know whether to apply sum or rate or increase like different PromQL functions or so. And then like based on your intent of the question, we will generate required PromQL expressions and populate it for you in the alert window itself, right? And then we can also suggest some of the thresholds based on your past historical data over the last 7 days or so that like a new user who doesn't know PromQL also could still sort of like by these examples or so, like by trying to just ask in English and then getting their PromQL queries, both like sort of get more familiarity with PromQL and more importantly get their work done with respect to generating the alerts or so. Right. So yeah, those are few things which I wanted to demonstrate. Happy to take any questions. Yeah.
You mentioned that you're using S3 for the data storage for all the log storage, right? But like, are you using it for for the cold storage, or is there a specific warm storage where you store it temporarily? Because what I've seen that for S3 the ingress and egress costs are very high. So if you end up storing all of the logs data, it will actually cost you more than the functions, serverless functions that random functions that you're running. So what is the strategy?
Yeah, so I can show you the architecture over here. We don't have a separation of warm tier and cold tier. That's what some of the existing observability vendors do, like store 1 day of data in disk and then rest for archival purposes to S3. Our architecture is built truly cloud native on top of S3 storage, where we will during the ingestion itself store data on S3 and serve the queries from there. So this is the central storage piece over there. We do have certain sort of like caching engines on top of that to keep it performant, because with S3, like apart from the ingress egress cost you mentioned, the other sort of like counterintuitive thing is it going to be performant or not, because of huge latency difference between, let's say, SSDs versus S3. But yeah, our platform is built with those constraints in mind, and we have optimized things such that both from a cost perspective as well as from performance point of view, we are able to meet the bar.
I have a couple of questions. Do you have any benchmark numbers that we can compare with other solutions?
Yeah, there are like our typical like P99 latency for metric queries we sort of like provide an SLA towards is 3 seconds. So we do have some of the internal benchmarks as well. The other thing we also have is effectively a public playground where we simulate a high cardinality workload for metrics. And this is where this public playground is ingesting 15.2 million time series which is a significantly high scale with respect to like metric time series, and you can effectively work with the product in this public playground and see the performance live as well.
That's okay, I can.
Yeah.
It's a small enough space. So first question about the cost. I checked out your site. It said there was an impressive graph of sorts comparing Datadog versus yours,
Yeah.
right? I think it was there somewhere here as well.
Yeah, that's correct.
So, I mean, there are going to be so many variables, right? So how do you claim that this is what it is going to be, depending on, say, the number of incidents, number of people watching the metrics at the same time? He pointed out, say, S3 ingestion costs, so on and so forth. We are on self-managed, self-hosted Grafana, Prometheus, that stack, and we also use Open Telemetry. And of course, you had mentioned agentless as well somewhere, right? So, do you aggregate on top of cloud metrics, CloudWatch and stuff? How does
Let me answer the agent part first and then come to the cost part. But great questions, by the way. So on terms of agents, our approach has been, and I think this will be in this as well, like we don't have our own agent which we supply. We are open source compatible, so we'll ingest from your Prometheus, Open Telemetry, or for logs, Fluentbit or Vector or whatever agents you are using, right? So that's what we do. And in terms of cost effectively, the comparison factor over there is, you're right that like there are so many factors which impact pricing or so, and that's purely a complexity which I think some of the vendors have pushed down to the customers. Like in Datadog bill, I think it probably needs a PhD to understand their pricing, because you need to count your containers, host, whatnot, how many log lines you are sending or so. We also wanted to, and like when I said like somewhere in the slide too complicated, right? I think the pricing is also one big piece over there, and our pricing we have kept it simple for metrics, like it is based on number of time series. Whether it's coming from infrastructure, whether it's coming from your application, custom metrics or so, that's also you will see in different vendors, custom metrics are much costlier than your infrastructure metrics. But if you think of it fundamentally, the amount of bytes you are storing is the same. Like if you are having a CPU utilization metric or your HTTP request latency metric, in terms of your number of bytes, you are going to store the same. So why a different pricing for that? So metrics pricing is based on that, like number of time series which you are emitting, and logs pricing is based on amount of GBs you are ingesting. All the S3 costs, because it's a SaaS platform, that's all within us. Like that's our problem to manage. How do we control our, let's say, egress cost and ingress cost, which is also where we do a lot of like things to avoid cross-AZ data transfer or whatnot. But that's all behind the SaaS system, because that's our operational cost. But for a customer, it's purely based on their volume of data.
Sure. Final question. You mentioned something about insights, where it gives, say, what could be a potential RCA or something. There was a slide about that. The best insights come by combining, say, application logs with infra logs.
Yes.
Right, and only then you can spot those trends over it. So how do you guys go about doing that? I couldn't see anything, but at least it wasn't obvious how you are monitoring the application side of things.
Yes.
What I could see was infra side of things.
Yeah, again a great question. So like for example, these are, if you see the labels associated with this metric, it has both the application side details like HTTP route or instance or let's say service name or so, which are your application labels, and then your infrastructure labels around container name or pod name or whatnot. And then the way we join all this information together is via service graph. Again, we use an open source agent to sort of ingest this data. And over here, like that way, like we have understanding of what is the dependency of a particular service along with its infra, like what is the CPU usage of it or memory utilization of it, which we can connect the dots on.
Awesome.
Thank you.
Thank you so much for this great talk. we have someone who is building right at the edge of what future of AI could look like. Please welcome Nishan, the founder of Agent R, where he and his team are building the world's first universal MCP server, a bold step towards creating truly autonomous and intelligent systems. In his spotlight about MCP and A2AP, Nishan will walk us through the evolution of agentic tools and the role they play in the journey towards AGI. Please welcome Nishan.
Thank you, guys. Let me just sit up. Just connect the Zoom. Let's go. Yeah, so let me just open up a